All right, so this week we are going to do a ARIMA time series analysis of some data that have to do with licensing of teenage drivers in California. So we have percent license of 16, 17, 18, and 19-year-olds from 2000 or 1986 to 2007. And two different things we think might have affected teen licensure rates during that time period. One is the ending of driver training, which occurred in 1991. And the second is when graduated driver's licensing, or GDL, was implemented in 1999. And we want to see if those affected the percent of teens who got licensed. So the first thing we need, and we need it for our APA write-up, is a plot of our time series. So we're going to go to Analyze, and we're going to go to Forecasting, and we're going to go to Sequence Charts. When we're in Sequence Charts, we're going to select our outcome variables, which are age 16, 17, 18, and 19. We're going to scooch those over into the variables box. Then we're going to move the first year variable to the time axis labels, not the year underscore one. So it's this one, not that one, to the time axis labels. And we'll click OK to make the figure. And there's our figure. And so we have to make it APA format, and we have to add these lines and whatnot. So I figured I'd just show you all how to do that here because it's not super intuitive. So double click on it to bring it up in editing mode. And the first thing we got to do is we got to start the axis at 0. So double click on it, click scale minimum instead of 10, make that 0. All right, that's one thing down. Next thing we got to do is under options, we have to hide our grid lines. And what else we got to do? So we need to add a label here. So how do we do that? So it's under options, and no, it's not. Data label, add markers. I don't think that's it. Show data labels. I don't think that's it. I think we click back on this axis. And labels and ticks, display label axis. There it is. Click that, click apply. It gives you some BS one there. So we're going to click on it and then click again. So we get an edit mode. We're going to change that to percentage license to drive. Click, hit enter, and it does that. So the other things we want to do are change this so it goes along the top. And I have not figured out an easy way to do this except to stretch it and stretch it. And let's try that again and stretch it some more. And it just refuses to do this. There we go. All right, so that gets it stretched along the top. And then we want to stretch this whole plot out. And the way you make it so you can stretch this whole plot all the way that way is you click down here and you get this sort of box. And one of these you can drag and stretch your plot. All right, we are getting there. So now we need to add reference lines at 1991 and 1999 and some text for that. So what do? We go to options and x-axis reference line. So it's currently set at 1997. We need to move that to 1991. And we want to attach a label to the line. Hit close. That's not the label we want to attach to the line though. Can I move it? So I take that back. Do not attach labels to the line. Okay, close. We want to add one more reference line as well. So options, x-axis reference line. The other one is at 1999 for GDL. Click apply and close. We have our two lines. These kind of get overwritten a little. That could probably be better. Let's see if we can do something like that to make it actually work. And no matter what I'm going to do, it's not going to work, is it? And so give up, all ye who enter. So we have to add these labels here as well. And so the way we do that is we go to insert text box, which in this version of SPSS, your guess is as good as mine. So text box. New, apply, close. That did not work. Undo. So options and text box. I don't know, that does not appear to be it at all. So let's keep trying here. Insert a text box. Properties, element type. New. Apply. Close. That like seriously didn't work again. All right, so we did somehow get some text boxes, so that's a good thing. And I'll shrink this one down so that it fits here. And I'm going to put driver training. Close. Let me edit you. Here we go. Driver training in high school. Yes, ends in 1991. So click out and here, and how do we get to get bigger font? There we go. That's closer to what we want. And left align it, and boom. All right, so we got another text box somehow up here. Geez, I got a bunch of them. Close. Here's one. So let's put that one over here. And similarly, let's add some text for graduated. Come on, click, keep clicking. Graduated driver licensing implemented. And that was 1999. Click out, click back on it, left align, shrink that a little bit, and maybe there. And we finally got an APA format plot out of SPSS, and it's really like pulling hair. But anyway, there it is. So if you copy that in, it's as close as you're getting to this. This is a slightly older version of SPSS, so it looks a little bit different. All right, that was a little harder than it needed to be. So now we need to get descriptive statistics for all of our outcomes before and after GDL went into effect and before and after they killed driver's education. So what we're going to do is go to the explore function. So descriptives and explore. And in the explore window, we're going to get all of our dependent variables, age 16, 17, 18, 19 license, put it in the dependent box. And then our intervention variables, driver training, GDL start, go into our factor list. Under display, we're just going to click statistics because we don't need all the plots and stuff. And when we click OK, boom, we get all sorts of stats before and after. Remember, 0 is before, 1 is after, 0 is before, 1 is after. So we got a bunch of numbers to fill in here. So let's just go ahead and do it. So percent licensed pre for 16-year-olds, pre-driver training anyway, right, is 28.13. And post is 20 points. Oh, this is percent. So we're just going to round it to 1 decimal point, aren't we? What do I say? Round first 2 columns, 2 decimals. Okay, fine. Fine. 20.68. 20.13, 20.68. So to get our differences, I think I'll just do that at one time. So I'm just going to get all my numbers in first. So 48.07 for 17-year-olds. So almost half of them used to get licensed. After GDL or after driver training was killed, it was 39 points. That's going to round to 10, right? 10. So 46.4, 48.07 and 39.10 for 17-year-olds. 18-year-olds is 64.95. So it's 64.95. So 2/3 of them got licensed roughly before driver training got killed. Afterwards, it was 56.05. So 56.05 and 64.95. 19-year-olds was 71.15 for forehands, and afterwards was 65.95. So 28.13, oops, sorry, 71.15, 65.95. So down here, we've got these same means as a function of GDL. So before GDL started, 25.94% of 16-year-olds got licensed. Afterwards, it went down to 17.22. So 25.94, 17.22. For your means, it's 44.61 for 17-year-olds got licensed. 44.61, and then 36.11. So that went down, if anything, 10 percentage points. 44.61 and 36.11. 18-year-olds was 60.75, got licensed. And after GDL, it was 54.21. 60.75 down to 54.21. Finally, 19-year-olds, 67.32. And after, it was not much different, 66.85. So 67.32 and 66.85. So here what we have to do is the mean post, so this minus the mean pre, that one. And then for this one, it's what we got here divided by the mean pre again, and then multiplied by 100. So I'll do one the hard way, and then I'm going to do this the easy way. So just to show you. So let's see here. I need our calculator. So it's mean post, right, minus mean pre. So it's 20.68 minus 28.13. You get negative 7.45, negative 7.45. And then we're gonna, here, it's taking that PPC3 C again and dividing it by the mean pre. So it's dividing it by this right here. So we'll divide by 20, oops. Divide by 28.13. So that gives us what proportion of the pre-level it changed, 0.26. Multiply it by 100 is the final step. 26.4, wait, what do we round this one to? You have to, first two columns, 2 decimals, round the last two columns to 1 decimal. Okay, so this is 7.5. And then this is 26.5. Minus 26.5. So it went down 7.5 percentage points. That's the difference between these. That 7.5 percentage points is a 26.5% reduction from the original rate of 28.13. So this is one way to do this. I'm going to show you how to use Excel to do this, because this is a pain in the butt. So I'm going to open Excel, which they do give you free in school, which is kind of nice of them. And I copied this table. Come on, Excel, you can do it. So big. Oh yeah, that's right. I got some crazy stuff that loads in that. So again, I copied this table. I'm going to go into Excel and I'm going to paste that table. And that gets us this looking thing. So I'll make these a little wider so it kind of looks like what our APA one actually looks like. And then to get these rows so they're not so wide, I will highlight them, double click on this line, shrinks it down, bam, there we go. So I'm going to use a formula. I'm going to tell Excel that this cell is equal to post minus pre, right? 7.45, and I need it to go down to 1 decimal place. So let me full screen it. So to do that, while I'm in that cell, I click that and it rounds it, and it uses Excel rounding rules. So I will pull that down to there. you can't keep going because this right here is a non-split cell. So I'm going to copy that, Control C, and I'm going to paste it here. And it should update the formula. C9, C9, right, minus B9. That's correct. So then for these ones, I'm just going to say U are equal to this one divided by the pre-rate, right? That will get me part, that's that divided by that. I'm going to throw some parentheses around that. And then I want to multiply, which is star times 100. And 26.4, whatever. Let's get rid of some of those decimals. So it rounds to 2. 26.5, which is what we got the other way. So actually, I'll pull that down, copy that, and paste it here. And there we go. So now the easy thing to do is copy this and go into our table. There you go, here, paste it. Hey, and you just got to make it up to font size here. So it's the same font size, which is probably 12, I guess. Yeah, it's 12. And then for these ones, same thing. Go here, copy, go into your Excel, or excuse me, your Word, paste, up into 12. And we have filled out this table per the instructions. Oops, oops. And it's a little easier than, I mean, you're going to make math errors doing that many like hand calculations, right? So hopefully this is what y'all got. And okay, number one's done. So what does this mean? So each of these is how much it changed. The negative means it went down from the, so the post minus the pre is negative, meaning it was something lower minus something bigger. So it went down 7.5 percentage points. So 16-year-olds, 7.5% fewer 16-year-olds are licensed after driver training ended than before. 9% fewer 17, almost 9% 18, 5.2% 19. Same thing for GDL. And then over here, we turn it into a percentage metric. So percentage points kind of, even though it is like it really is just this minus that, this turns it into something more universal. It's the percentage of the original series. How much did it go down? So this is percentage point. This is percentage, okay? So relative measure, this is an absolute measure. So when you divide this 7.5 percentage point reduction by the pre-rate, multiply it by 100, you get that 16-year-old year licensure went down 26.5%. 7.5 percentage point reduction is the equivalent of a 26.5% reduction. 9 percentage point reduction for 17-year-olds is an 18.7% reduction for 17-year-olds, etc. You can see the big ones here are, that's pretty big, 30, that went down a third basically for 16-year-olds after GDL went into effect. This one's really small. So let's keep going. We are going to run our initial time series. So in the Analyze menu, we're going to go back to forecasting and we're going to create traditional models. In the time series modeling window, you're going to select your outcome variable and move it to dependent variables box. For this first one, I just want you to do age 16% license, just to keep things a little less crazy. So then we're going to click the criteria button. In the time series model criteria window, select the radial for ARIMA models only, that one. Click the continue button. That says just do ARIMA models, SPSS. Click the statistics tab that's up top here. Under statistics for individual models over here, we want to select parameter estimates. Don't change anything that's default selected, leave the rest of this stuff. Click the plots tab. In the plots tab under plots for individual models, that's down here, you need to select fit values. Boom, that gets you that predicted versus actual that was in the lecture. And residual autocorrelation function and residual partial autocorrelation function. That's going to get you your ACF and your PACF that you need to diagnose the model. Click OK to run the analysis. And you've now officially ran your first time series analysis probably ever. And let's see what we got. So from the model description table, where's that model description? what model did SPSS choose for 16-year-olds? It chose a 0-1-0 model. So in here, hopefully you put 0, or you will put 1, 0. And I will bold and highlight that just so we see it. From the model statistics table right here, what is the number of predictors? Number of predictors is 0. So it picked 0 predictors. This is that model where it just says each score is equal to the one prior to it. The difference, you difference it from the one prior to it. So it's telling you there was a trend in here. What percentage of variability did this ARIMA model predict? That's your stationary R squared. 0. 0%. 0.0% of variability was accounted for by this model. Why? It doesn't have any parameters in it except the series mean, which is the constant, and note it's not significant. So do any of the spikes in the ACF or PACF go past the 95% confidence intervals? So here are the ACF and here's the PACF. And we're looking to see if any of these bars go beyond these lines for the ACF or these lines for the PACF. Short answer is yes, right there. So this is lag 1, lag 2. This says that each observation is correlated with the one 2 before it in this series. For whatever reason, a year, the percent of teens who got licensed, 16-year-olds who got licensed in a year is correlated with the percentage who got licensed 2 years prior to that year. Okay, that's weird. So do any of the spikes for the ACF or PACF go past the confidence interval lines? The answer there is yes, right? It's this one right here at lag 2. So bold and highlight. If so, at what time period lag? 2, right there. So just scooching over, that's time period 2. And again, that just means even after we built this model and we differenced it, each year is correlated with the percent licensed each year is correlated with the percent that got licensed 2 years earlier, which is kind of weird. Okay. So how well does this model predict the actual licensure rates according to the plot showing the observed versus fit? So here, it follows the pattern pretty damn well, right? But it's shifted because we differenced, it's shifted forward 1. So this is one where there's no wrong answer, but I'm going to say the following. The pattern fits the actual licensure rates, but is shifted forward 1 period. That's where like this spike should be there, right? So it shifted forward, that spike should be there. And that's just due to the fact that we did differencing. So boom, 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 get that in there. So it's kind of amazing how well it fits the pattern. It's just shifted forward 1, right? But we got a problem here with this spike. So even though this model is not perfect, I do tell you to go ahead in this next step and put driver training and driver ed into this model and see what happens. The idea is maybe it'll take care of the spike by putting in the intervention effects. That's sort of the thought. So we're going to go back to analyze. We're going to go back to forecasting, create traditional models again. And in the time series modeler window that's here, we are going to move the independent variables, driver training and GDL start to the independent variables box. So driver training, GDL start, pop it in that box. All right, click the criteria button. And in the time series expert model window, select the checkboxes next to each intervention variable there and there that says include this in my model, SPSS, if they're significant anyway. Don't change anything else. Click continue and then click OK to run the analysis. So now we're throwing in those time period variables for when those laws went into effect to see if they clean up the model and whether it ends up any better. That's what we're doing. So from the model description, what model did SPSS choose for 16-year-olds? It still chose 0, 1, 0. So that's what we're going to put here is 0, 1, 0. What's that model mean? There's no autoregressive, there's no moving average parameters. All it did is integration, which means subtraction. It subtracted each score from the one before it to get rid of a trend. And so if you look at 16-year-olds, 16-year-olds are here. It's saying it was trending downward, and it kind of was, right? Except for the weird spikes. It was trending downward over time. So it's taking out that effect. That's what it's doing with the differencing. So let me bold and highlight this. From the model statistics, what number of predictors is 2, right? It's got 2 in there. It's got driver training and GDL are the 2 that it happens to have. Told it to include them, and it ended up including them both. So what percentage of variability did this ARIMA model predict? Stationary R squared is 0.568, so 56.8%. Not too bad. 56.8% of variability was accounted for by this model. So we went from 0 to 56.8% by adding these 2 intervention effects. Cool. All right. So scooching along, using alpha less than 0.05, complete the following. The estimate and t-value come from the lines in the ARIMA model parameters. So that's this table right here. And numerator, all right, so called numerator for each intervention. Round everything to 2 decimals, make sure to asterisk the t-value of SIG's less than 0.05. So here we go. So here we have 16-year-olds, different, so that's not numerator. Driver training numerator. We've got an estimate of negative 6.929. And I tell you to round to 2 decimals, so that's negative 6.93. Negative 6.93. That means, well, let's see if it's significant first, I guess. Our t-value for that is negative 3.70. Negative 3.70. The SIG value for that is less than 0.05, so it gets a star. So what the heck does that mean? That means that driver training ending is associated with a 6.3 percentage point reduction in 16-year-old licensure in California. And it's because it's significant. How about GDL? Did that affect their licensure rates or appear to? GDL start, numerator, 6.89 negative. So we'll put negative 6.89. And the t-value for that is negative 3.68. And that is also got a SIG that's less than 0.05. Oops. So it gets a star. And let me highlight and bold those. So 16-year-old licensure also went down. Let's just call these both about 7 percentage points when driver training ended and when GDL started, because they're both significant. Both those things negatively impacted 16-year-old licensure. So here it went down about, so this versus the post period is about a 6% reduction. The rate here versus here is also another 6%, or excuse me, 7% reduction, 7% reduction. So yeah, it looks like those 2 things reduced. I mean, basically, if you make it harder to get a license, yeah, fewer people get licensed. So some people asked about these little things here, and what this is, these are real data, is that they made it so that you could get grandfathered into the program. So what that meant was you could, if you applied early for your license, you weren't subject, or sorry, you got the driver education for free, or the driver training for free. So a bunch of kids came in, got their permits and whatnot, and then it dropped down. Same thing out here with GDL, they grandfathered it. If you applied for your license before this went into effect, you weren't subject to the provisions, which were you had to hold your learner permit for 6 months. When you got licensed, you couldn't drive with your buddies for a year, and you couldn't drive, I think it's after 11 o'clock at night for a year. And so a bunch of people, a bunch of teens, 16-year-olds came in early, got their permit, and then it dropped down again. So these are just artifacts of the way they implemented the program that people rushed in, but it is a little funky looking. So briefly summarize the findings of the ARIMA intervention effects in words. What impact do these interventions appear to have on licensure rate of 16-year-olds? So driver training ended, resulted in about a, I'll do it in a 6.93 percentage point reduction in licensure. So they said, yeah, screw this. I'm not going to get my license. They made it harder. So when GDL started, also reduced licensure, right? It's 6.89. So I'm just going to cheat and copy this and 6.89. So the easier way to do this is just say, hey, it resulted in about 7 percentage point reduction in 16-year-old licensure. All right, do any of the spikes in these, oh yeah, we didn't diagnose the model. Do any of these spikes go beyond the confidence interval lines? The answer is no, they don't, do they? So none of these go past the bold lines. So it looks like this model is not that bad. So the answer here is no, none of these spikes do go past the confidence interval lines. Oops. And at what period lags? This is, I don't know, NA, not applicable. None of them do. So how well does the model appear to predict the actual licensure rates according to the plot shown in the observed versus fit series? Here's that one. Interesting. So observed is red, fit, that is what comes from the model, is blue. And what you see is it's close except for those weird artifacts, right? So it's a little bit shifted. It generally follows the pattern. It's pretty close to the red line except for there and especially here, right? So how do you want to say that? I'm going to say good, except for the spikes before the law changes. Something like that. I mean, I think they are pretty good, except for those, the spike there and the spike there. All right, let me save that. So we are going to run our final time series analysis now for all the variables. So instead of going through and making you do 17-year-olds and making you do 18-year-olds, I'm just going to say, you know what, this model, because I did this analysis, works good for 17, 18, and 19-year-olds for all age groups. So we're going to force a 0-1-0 model for all age groups. So let's go to Analyze and Forecasting, create traditional models, add the other 3 outcome variables, 17, 18, and 19, 17, 18, and 19, throw them over there to the dependent box, leave age 16% where it is. Change the method drop down to ARIMA. Method, ARIMA. That's going to force SPSS to do an ARIMA model. Click the criteria button. And because SPSS chose a 0-1-0 model for 16-year-olds, we're going to use that same model for all the other age groups as well. This means we need to change the 0 for difference in D in this menu to 1 as shown below. So here, under non-seasonal, we have to change this middle one to a 1. We've now done it. Don't change seasonal because it's not a seasonal model. Don't change any of this crap. It's a 0-1-0 non-seasonal model. So then click the transfer function. Because we are differencing the outcome variable, we also need to tell SPSS to difference each intervention variable too. It did it automatically for 16-year-olds, but here we have to make sure it does it. So click on each independent variable. So I clicked on that one, change the 0 for difference to a 1. So notice it's not in the middle because SPSS people hate us apparently. Change this bottom one to a 1. Okay. As shown, the difference is the last row, not the middle. Do this for both. So we got to do it for GDL as well. 1. And when we look at them, they're both being differenced at 1, just like the dependent variables are, because we're doing a 0-1-0 model. So click continue and click OK. And it now ran a 0-1-0 model for all of the age groups. All right, so based on the results, using alpha 0.05, fill in the table below, blah, blah, blah. The stationary R squared comes from model statistics, right? And the estimate and t-value come from the ARIMA parameters table on the line called numerator, the lines that are called numerator. Round everything to 2 decimals, make sure to asterisk the t-value of sig's less than 0.05. So let's do this. So what model did it pick for 16, 17, 18, and 19-year-olds? That's what goes here. Well, for each one, it was 0-1-0, right? So that's what we're going to put. And then we're going to cheat and copy and paste it after we bold it, or yeah, copy and paste it. It's a 0-1-0 model. This one is a 0-1-0 model. All these are 0-1-0 models. Our stationary R squared comes from right here, model fit statistics stationary R squared. So to 2 decimal points, they say to round everything to 2 decimals. So this one's 0.57, right? You don't have to put the leading 0 because it can only go from 0 to 1. And it can never go above 1. It's okay to leave off the leading 0 according to SPSS format. So 0.57 for 17-year-olds. So that's 57% of the variability of 16-year-olds is accounted for with this model, which if you go up and look, that is 56.8, which is 57. It's the same number. So for 17-year-olds, it is the 33.33. 2 decimals. For 18-year-olds, it's 0.17. And for 19-year-olds, it's 0.28. So that is just like any other R squared, it's the proportion of variability in the DV accounted for by the model. In this case, it's an ARIMA model. So then we need our estimates, which happen to be percentage point change. So we go to 16-year-olds is this stuff right here, then 17, 18, and 19. We need the numerator line, and our numerator line for driver training ending is 2 decimals, 6.98 negative. So negative 6.98. Our t-value for that is negative 3.54, negative 3.54, and it gets a star because it's significant. GDL numerator, 6.94, so negative 6.94, right? And that is a t-value of negative 3.52, negative 3.52. It gets a star because sig's less than 0.05. So both driver training and driver education, any driver training and GDL reduced 16-year-old licensure by about 7 percentage points. Each of those did. All right, 17-year-olds, what they do. So find the numerator line for driver training. It's negative 1 point, that's going to go 50, right? Negative 1.50. And the t-value is negative 0.98. Negative 0.98. Does it get a star? No, sig is not less than 0.05, right? So how about GDL? What did that change their licensure rates? Well, numerator for GDL is negative 4.36, negative 4.36, 4.36 percentage point reduction. T-value is negative 2.86, negative 2.86. That gets a star, right? Because sig is less than 0.05. So for 17-year-olds, driver training did not significantly reduce their licensure rate. However, driver ed did, or GDL did by about 4.36 percentage points. For 18-year-olds, GDL, driver training numerator is negative 2.09. So negative 2.09 was the reduction. Is it the t-value is negative 1.33. Does it get a star? It does not. It's not less than 0.05, so not a real reduction. For GDL, the value here, this is all going to round to 2.0, right? 2.00, because that would round that, which around that, which around that. So it's, and it's positive, by the way, which is the first one so far, 2.00. And significant, or sorry, 1.28 is our t-value, 1.28, 28. And significant, no star. So neither driver training nor GDL impacted 18-year-olds' licensure rates. Neither one was statistically significant. These are very small, right? Okay, finally, 19-year-olds. Driver training numerator, negative 2.33. The t-value is negative 1.29. Significant, no star. How about GDL? GDL numerator, 4 point, it's positive, 4.05. And the t-value is 2.24, and it's positive. Get a star? It does, right? That's less than 0.05. So for 19-year-olds, driver training did not significantly change their licensure rate, but GDL increased it. It's positive by about 4 percentage points. That's the findings so far. So let me bold all this stuff and yellow and save. So do any of the spikes in the ACF or PACF go past 95% confidence interval line, suggesting residual autocorrelation? So we got a bunch of them here. So we're seeing if any of these spikes go past the dark lines for any of them. The answer is no, right? So none of these ones do, and none of these ones do. So even though there's some big spikes, they don't go past the line. So the answer is no, there is no significant residual autocorrelation present for any of the series. So what lags? Again, in A, these models appear to have reduced all the autocorrelation. So, all right, let's briefly summarize the findings for each one of these. So I'm going to cheat a little bit since we already did these. All right. For 16-year-old driver training, we're looking at these two things, both of which were significant. So the first one, whoa, don't do that, resulted in a 6 points. It's 9.3, it's 6.98. Did I mess that up earlier? Oh God, please tell me I didn't. It's not there. There we go, 6.93. No, it was that before. What the hell changed? Who knows? Okay. 6.93, and now it's 6.9. Did I screw it up down here? 6.9 numerator 8. I did not. Like literally, what the heck's different? 6.98. Okay. I can just copy the wrong one. I guess not. Anyway, moving right along. So driver training significantly resulted in a 6.98 percentage point reduction in 16-year-old licensure. How about GDL? It's also significant. So I'm going to copy and paste this in. GDL for 16-year-olds resulted in about a 6.94 percentage point reduction. Again, statistically significant. So 6.94 percentage point reduction. I'll line those up so it doesn't get too crazy. How about 17-year-olds? Driver training, not significant. So I guess I'll paste this in anyway, just to make it easier and say, and no significant change in licensure. Driver training did not appear to positively or negatively impact 17-year-olds. Why? Driver training for 17-year-olds, it was only, if anything, it only went down at 1.5 percentage points, not significant. How about GDL? GDL reduced their licensure rates, right? So we'll paste that in here. That resulted in a 4.36 percentage point reduction, 4.36 right there, percentage point reduction, significant in their licensure. 18-year-olds, neither driver training nor GDL starting had a significant impact, right? Neither one was statistically significant. So for all intents and purposes, this is just chance variation. So it's this again, no significant change in licensure, and it's going to go on both lines. Why? Again, just in case you're like, what? So these were the estimates of the change, up 2 points, down 2 points, neither of which was at a sig value that was less than 0.05. So for all intents and purposes, no change. This is basically zero. All right, how about 19-year-olds? We got some mixed findings for driver training. That was the estimate, not significant. So driver training did not appear to result in a significant change in their licensure rates. But GDL, 4.05, it's positive and it's significant. So that one did. So let me copy one of these different ones. And we got to change a couple things, resulted in a 4.05% percentage point, not reduction, increase in licensure. So for whatever reason, GDL drove more 17-year-olds to get their license. It's kind of an interesting effect. So write up the results in the form of an actual APA results section and use the template. So hopefully you guys get through this week while I'm out of state and are able to finish this and post your questions in the discussion, because I can still answer them there. And good luck. All right.